This is the first of a few examples that look at linear transformations of discrete random variables. We want to calculate the expected value, variance and standard deviation for the probability distribution shown here. So, expected value, we know that's going to be 1 multiplied by 0.25, add 2 multiplied by 0.5, add 3 multiplied by 0.25. That's 2, and I should really have spotted that because if you look at it, it's completely symmetrical. So the mean would be exactly in the middle. I didn't really need to calculate it. Now we need the variance as well. So that's the expectation of x squared. We know that's going to be 1 multiplied by 0.25, add 2 squared, 4 multiplied by 0.5, add 9, which is 3 squared, times 0.25, and then we're going to, let's go to decimal, we're going to do that answer, take away 2 squared, that's the expectation squared, that gives us 0.5, and so finally SDX is the square root of the variance, so square root of the last answer, which is about 0.707. Let's give that as 0.7071 to 4 decimal places. Now consider the probability distribution of y. Write a relationship between x and y in the form y equals x plus something. Well, just looking at them, it looks like we've just added 5. So y equals x plus 5. We now want to calculate the expected value, variance and standard deviation for y. So expectation of y, variance of y, and the standard deviation of y. So it's a symmetrical distribution again, so straight away we can just go for 7 here. So let's do the variance. So we want the expectation of y squared, so that's going to be 36 multiplied by 0.25, add 49 multiplied by 0.5, add 64 multiplied by 0.25. And then we need to take away from that 7 squared. And that gives us 0.5, which means the standard deviation of y would be 0.7071 to 4 decimal places. Now, the expectation of y is, if we look at it, the expectation of x plus 5. So y is x plus 5 and the expectation of y is the expectation of x plus 5. And that's because adding to x has moved the distribution along, so the middle is now at 7. However, if we look at var y, that's just equal to var x. And the standard deviation of y is equal to the standard deviation of x. So what do we notice? Well, the mean is affected by just adding a number on, but the dispersion, the variance and standard deviations, which are both measures of dispersion or spread of data, those are unaffected. And that's not surprising because 6, 7, 8 is spread out exactly as much as 1, 2 and 3. So in other words, if we just add, we'll affect the expectation but not the variance or standard deviation.